Today we finally talk about linear advance. So there's a couple reasons why I've been procrastinating on linear advance testing. One, it's kind of hard for me to understand and just a little bit confusing on how it works. But two, I was hoping they were going to make some improvements in Marlin 1.1.9, and they have. We now have linear advance 1.5, and that removes a lot of the considerations that you had to make when setting up version 1.0. Now, before we get into the configuration of linear advance, just what is it? And I think you need to understand first that a 3D printer is a linear machine. If you move X, Y, or Z a certain amount, it's going to move in a straight line that exact amount, and then move back when you tell it to move back that exact amount. And that's all fine and good until you get to the extruder. And until linear advance, the extruder tried to move in that same linear fashion. If you needed 100 millimeters of filament, it would get you 100 millimeters of filament. But you might not need that much filament depending on the part that you were trying to print. And that's what I'm trying to convey with these test models here. So this part was printed at 120 millimeters a second with linear advance off. And that's because the faster we print, the more exaggerated this issue gets. So we take off printing down this line, we accelerate to speed, and then we decelerate, and you'll start to see just a little bit of feathering here as we get slower. But then when we get to the corner, the whole model looks pinched. The corner's been pulled out a little. And that's because as we head down this line and print, we requested a certain amount of filament be extruded. So it extruded that amount, no matter what direction you're moving in. So we came down here, we're still extruding as we slow down, and we slightly pause to go in the opposite direction, and then you're left with extra filament in that corner, causing this condition. So that's where linear advance steps in. When you hit that rate of speed, and then you slow down, it compensates for that feed rate of the extruder. It's probably a little easier to understand with the diagram that they give you on the Marlin website. So this is the calibration pattern that they give you to set up linear advance, but it's a great example to show you what's going on. So you're printing at a slow speed, and then you move to a faster speed. The feed rate of the extruder is the same, but the extrusion slows down until that feed rate picks up. And then when you're going from the fast speed to the slow speed, the extrusion gets wider because it still needs to catch up with that slow move. So it's kind of like a governor for your extruder. As speeds change or filament needs increase or decrease, it's going to try to compensate for that. Now you will have to calibrate for different types of filament that you use. But the good news is that what the value is for one PLA will probably work for all PLAs. But you will have to change them for things like PETG or flexible. And that's why I recommend that you set these things up inside the slicer at the filament level. So it changes as you move to different types of filament. Also in version 1.5, things are a little easier because the K value when you calibrate actually means something. It's a filament compression value per millimeter. But we'll see more of that in a second. So now let's head in and figure out how to get this thing calibrated. So this is Marlin 1.1.9 and it has already been configured to work with my printer. But let's go take a look at linear advance. So we'll head over to configuration_adf.h. So we'll control F and we'll search for linear. And that'll take us to linear pressure control. All you have to do to enable linear advance is uncomment the lin_advanced line. So we'll uncomment that. Down here you can hard set your K value, but that's if you never change filaments. We're going to change ours in the slicer. So I like to set mine to 0. That leaves it unset by default, and the G-code will set it up for every print. And that's all you have to do to get started. The next most important thing is this link right here. This will give you all the info you need to know about getting things calibrated and set up correctly. So we'll click on that. Now, you can read through all this information if you like. There's a lot of good stuff in here. But what we really need to know is how to get things calibrated so we know what K value to use. And in the calibration section, they provide a K factor calibration pattern, and you can generate it from here. So we'll click on the generator. And here's where you're going to enter all the settings for your printer. These values are important to make sure linear advance works correctly, and you also need to know that your extruder is calibrated correctly. So I would run through a calibration on the filament that you're getting ready to use before you attempt the linear advance setting. So let's just run through the settings real quick. Nozzle temp, we're going to go with 210. Bed temp, we'll go with 55. Retraction distance, I use 0.8. Layer height, 0.2. We'll set bed shape. Bed size, I'm going with 230. Bed size Y, 210. Origin of bed, mine is not in the center, mine is in the corner. We're going to use millimeters. Slow print speed, 20 is fine. Fast, 70 is fine. Movement speed, I'm going with 180 because that's the usual speed I use. Retraction speed, I use 35. Acceleration, I want that to be slow during the test, so I'm going to save that at 500. All of these values will default to the firmware settings, so that's fine for me. Pattern, linear advanced 1.5. Pattern type, standard, that usually works okay. And I'm going to leave these values default for the first run, so I can show you what it does. So all these default are fine for now. We're going to use the default pattern. Line ratio 1.2 is fine. Z offset will be used from the default that's in the firmware, so we don't need to set that to anything. We do need bed leveling, so it will send a G29 command before it prints. I don't use firmware retract. Extrusion multiplier as default is fine. We do want to prime the nozzle, and priming settings and dwell time are just fine. So when you have all the settings just right, go ahead and generate G-code. It will show you the G-code over here, and you can see each line before it prints, it sets a different K value. And this is the linear advanced value. So we're going to start at 0 and bump it up 0.2 for each new line. So we can download that file, and then I'll load this file on my SD card, and we'll print out the test pattern. So this is all you need to get started to configure linear advance. But I don't want to upload it yet. I want to show you what a calibration pattern looks like before and after linear advance is enabled. I think it just makes a little more sense. So let's go ahead and run that G-code we just created on the printer before linear advance is enabled. So the first test grid I wanted to show was what it looks like before you enable linear advance. I think it's a little easier to understand what it's doing if you can see it before or after. So this one doesn't have linear advance enabled in Marlin yet. When it's finished, you can see that this is the 0 to 2 scale. Each one of these lines is 0.2 different from the next. You can see before linear advance is enabled, it's not actually making any adjustments as it goes from slow to fast back to slow. Every one of these lines is identical. So that's what the test pattern looks like before linear advance is enabled. Now we'll go back into Marlin and we'll upload the changes to enable linear advance and run the same test again. So everything's all set up, K value set to 0, all we need to do is upload. So tools, make sure you're on the right board, make sure you're on the right COM port, and we'll hit upload. Upload is complete. Now we'll start that same G-code again while linear advance is enabled. So the first test with linear advance enabled is now running. So remember, this is the 0 to 2.0 test again. These are 0.2 increments all the way up. You see all these lines up here, the advance was so far, it didn't even complete the line. So what you're looking for is the line that looks the best. So this is the 0 line where there hasn't been any change at all by linear advance, and this is the 0.2 line. As the slow move starts to go to the fast move, during the fast move, the line gets a little wider as the extruder starts to catch up. And then when it goes back to the slow move, the line gets a little thinner as it tries to compensate to go to that slow move. This is what we're trying to avoid. So no linear advance isn't enough, of course, but 0.2 is too much. So we need to alter our test. So back to our calibration G-code creator. All these settings are going to be fine, except for the pattern. We need to make this pattern a lot more granular for this printer. So the starting K value should still be 0 because that's pretty useful for comparison. But since all the lines that have a greater value really weren't useful at all, let's make the ending K value 1. And the K factor stepping, let's reduce that down to 0.05. This should give us 20 lines with a 0.5 increment for each. So let's generate the G-code. Now you can see the M900 commands are a lot more granular, and we'll download it. Now we're getting ready to run our longer, more granular test. Now as this test is running, watch the extruder motor, and as it changes, as it goes up, the greater linear advanced values. The low values are here, the high values are here. As the linear advanced value gets higher, you'll notice the bounce back is a lot greater. That's it trying to compensate using linear advance. Now let's get a close-up of this scale. So now we have a scale with a 0.05 iteration on it, and it's much longer. So we have our 0 line where there's no change at all, and then we have our 0.05 line, where it's just a little bit too thin. Then we move up to the 0.1 line, and it's almost perfect. If anything, it's just a little bit too much advance. Every line after that, it's just a little bit too fat after it has switched over to the fast move and trying to compensate for that increased flow, until we get to the top where it can't even complete the line again. So judging by the look of this scale, 0.1 is going to be a great place to start. So now we know roughly what our K value should be for this filament. This is PLA, and it'll probably work on most PLA filaments. All we have to do is slice our models to include that M900K command, and then it will start utilizing Linear Advance automatically because it's already been enabled in the firmware. So let's head into the slicer. So let's load up our test model, and let's head to filament settings. Now in Slic3r, all your filaments can have their own unique custom G-codes. It might be different in other slicers, but this is how I know how to do it. So I'm going to select my generic PLA filament setting. I'm going to go to custom G-code, and I'm going to enter my Linear Advance setting for PLA filament. That'll be M900 K0.1. And I'm going to save that as PLA LA for Linear Advance. There are a few slicer settings that you need to be aware of when you enable Linear Advance. If you're using any type of volumetric value, you need to disable these, or any of the values that you use that say something about coasting at the end or extra length on restart. You don't want to use any of these while Linear Advance is enabled. These features are trying to achieve the same thing that Linear Advance does, and it's just going to get things confused, so make sure none of that is enabled before you try these out. So let's head back to the platter. So now when we slice this file, it will now include that M900 command to enable the Linear Advance with that K setting. So let's go ahead and slice. We'll export the G-code. Let's just have a quick look at that G-code. And right here, you can see our M900 command. So now I'm going to reprint that test object with Linear Advance enabled, and I'm going to use the default speed settings. The maximum speed for infill is around 60 millimeters a second. And let's compare before and after. So this edge of this model provides a pretty good example. This is before Linear Advance. You can see where it's pulled up in the corner. And this is after. It's almost completely smooth. So it definitely looks like Linear Advance is enabled. Now Linear Advance isn't going to be effective on short print moves, and the issue that Linear Advance tries to fix isn't going to be very obvious on slower print speeds. But with Linear Advance enabled, we should now be able to print at faster speeds without seeing that issue. So let's test it. Let's reprint this object at 120 millimeters a second with Linear Advance enabled and compare the two, before and after. So here we are at 120 millimeters a second before Linear Advance and after Linear Advance. The corner after Linear Advance is much more round. It's a lot straighter. This one is really pulled out. But you can see a little bit of backlash down here on the Linear Advance part. So the front of this is almost rounded. So that tells me at a really high rate of speed, Linear Advance is actually set just a little bit too high. So maybe a 0.09 would be just a little bit better, depending on the print speed that you're using. So you've seen the testing results. Should you run right over to your printer, upgrade your firmware, and enable Linear Advance? Well, if you're using a setup like this one with a direct drive extruder and reasonable printing speeds, I don't see any reason why not. You should be able to print at 100 millimeters a second, just like you do 60 millimeters a second, and the printing results should be the same. Now there are some considerations to be made, like Delta printers and Bowden setups. Linear Advance will reduce your printing acceleration if it needs to, and that's the whole point of a Bowden setup. But on the other hand, Bowden setups benefit the most from these pressure advanced systems, like Linear Advance. If you get Linear Advance set up just right, you should be able to reduce your retraction length greatly, and therefore increase your printing speed. Now you should never go over a K value of 2. If you're configuring a Bowden system and you realize that you need to go over that K value of 2, pretty much the only option you have left is to shorten your Bowden tube length. If you do set it up with a K value over 2, you're going to get some really unpredictable results. So let's recap. Make sure to disable any pressure assist setting you might have in your slicer. Make sure you calibrate your extruder well before you start to set up your Linear Advance. Not all filaments are going to have the same K value. You're going to have to give extra consideration to anything that has a Bowden setup. M900 is your friend. Never go over a K value of 2. And most importantly, Linear Advance is awesome. Lots more information in the description below. I hope you found this helpful. If you did, please consider giving this video a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.